So I would say that we started investigation the methane issue in the Arctic in 90s of the last century, and we started from the terrestrial ecosystem, freshwater ecosystem, and then about 8 years ago switched to studying the East Siberian Arctic shelf. And actually we've been studying it for the last 8 years, continuously, year by year by year, conducting 1 or 2 expeditions a year. That hydrocarbons are produced within the sedimentary drape was sealed. It was not released for thousands of years during that time when the subsea permafrost sealed these deposits and prevented the methane escape to the atmosphere. That is why we are telling that this should be the largest hydrocarbon stock in the world over there. The methane hydrate is not a specific type of source of methane. It's just a reservoir to temporarily preserve the methane of any kind. There should be a natural gas, the thermogenic, the biogenic. Once this gas comes to the hydrate stability zone, it becomes a hydrate, but it's only for a certain period of time. It is a reservoir to temporarily preserve certain amount of any type of methane. The depth of the water column is very important because the water is where methane oxidizes. The shallower the water column, the less time is required to this methane to pass by through the water column and escape to the atmosphere, as compared to the mean depth of the world ocean, which is few hundred meters up to kilometers. The East Siberian Arctic shelf mean depth is only 50 meters. The ice coverage prevents water from mixing, in terms of wind mixing, because it's just coverage, ice coverage. The loss of ice coverage, of course, leads to accessibility of water, of surface of the water by wind. And when there is no wind, the emission happens. How emission happens? So the methane molecule escapes from the sea surface to the atmosphere. Of course, when the wind mixes the water column, so all the methane, the entire inventory, so all the methane which is included within the water column escapes to the atmosphere. So it helps the methane inventory to escape, actually. The deeper the mixing, the more fraction of methane escapes to the atmosphere. This particular sediment layer, which is 53 meters, doesn't seal this methane escaping from the seabed deposits any longer. It provides us with gas migration pathways. This is what is significance of this. There is a potential risk that if warming continues, the larger, maybe great and massive amount of methane could be released from this Siberian Arctic shelf. Of course, there is a potential risk. And in terms of potential risk, I would say that the Siberian Arctic shelf is the most potential because, as we said, the carbon pool is huge and the water is very shallow, and the warming occurs stronger than in different areas of the world ocean. And of course, it is a potential risk. So the methane in the atmosphere, the total amount of methane in the atmosphere, in the current atmosphere, it's about 5 gigatons. The amount of carbon preserved in form of methane in this Siberian Arctic shelf is approximately from hundreds to thousands of gigatons. And of course, it's only 1% of that amount is required to double the atmospheric burden of methane. But to destabilize 1% of this carbon pool, I think it's not much effort needed, considering that the state of permafrost and the amount of methane currently involved. Because what divides this methane from the atmosphere is a very shallow water column and a weakening permafrost, which is losing its ability to seal, to serve as a seal. And this is, I think it's not a matter of thousands of years, it's a matter of decades, I think. Maybe at most 100 years, but I think matter of decades.
I believe that it would happen anytime.
It might potentially happen because just because this area is very seismically and tectonically active, and there was some investigation that the tectonic activity is increasing, and the seismic activity is, what is seismic activity? It's destabilization of these grounds. It's just mechanical forcing destabilization. So it's additional pathways for this methane to be escaped. And many factors, I would list you many factors that might, that are very convenient and convincing for us, so that might happen. Not any time. I think any time sounds like it might happen today, it might happen tomorrow, the day after tomorrow.
Might.
You think so?
I'm in person. No, but
Igor is a very convinced person because he spent a lot of time over there. And if, for example, a few years ago we could reach the certain sites from the fast ice. Fast ice is annual ice, and we can reach quite easily to certain sites, hundreds or tens of kilometers from the coast. But last 2 years we couldn't do that because the ice was broken. It was polynias, it was brines, it was leads. So that means that, and where the sea ice should be about 2 meters thick, it was 40 centimeters thick. That means that the processes, all the processes that serves destabilization of everything, of the sea ice, of the water column, of the currents increasing, the currents, I mean the movement of water beneath the sea ice increased. So everything looks anomalous, even from our experience from this 10 years. Everything looks anomalous, and this is what makes him thinking that, making him think that the worst thing might happen.
No, we cannot exclude this. Maybe it's 1%, maybe it's less, but we cannot exclude because.
Shortly speaking, we do not like what we see there. Absolutely do not